so today we are looking at Chapter 1, Lesson 5, Rational Numbers. So rational numbers are a part of everyday life. You see them when you look at the price of how much something costs on a price tag, highway signs, charts. They can be written in different forms though, and to compare rational numbers, it's easier to convert the numbers into the same form. So first, let's write down what a rational number is. A rational number is a number that can be expressed in the form of a over b, where a and b are integers, are numbers, right? Could be positive, could be negative. And b is not 0. So that means the denominator is not 0. Some examples could be 2 over 5, a repeating decimal, 3, 3, 3, 3, 3, so the line over top, -6, or 3 1/2. So it can be written in many different ways. So we want to look at comparing these rational numbers. So we're going to start with comparing -1/2 and -3/4. So our first method is to create a number line. Okay, so here's my number line. And what we want to do, so what I did is I broke apart the lines between 0 and -1 and put it into fractions. So this is -1/2 would be right here, and -3/4 is right here. So therefore, -3/4 is farther to the left on the number line, so it is the lesser number. So -3/4 is less than -1/2. The second method, you are going to take -1/2 and you have -3/4. You want the denominator to be the same. So you can see that 2 can go into 4 2 times. So if we multiplied -1 by 2, whatever you do to the bottom, you have to do to the top. Then that's going to equal -2 over 4. So now we have -2 over 4 and -3 over 4. 3 is a bigger number, but it's farther on the left. It's farther away from the number 0 because -3/4 is farther away than -2/4. Therefore, same thing is true. -3/4 is less than -2/4, and -2/4 is equal to -1/2. So either way, whatever way you would like, you can use the number line or you can make the denominators the same. So now let's look at this next one, comparing -2/3 and -1/6. So you can either, let's do both ways, create a number line. Okay, so I created my number line and I broke the number between 0 and 1 into 6 spots. But the 3 is saying that there's only 3 lines between the 0 and the 1. So the yellow lines represent 3 spots. So -1/6 is going to be right here. That's 1 dot out of 6 dots to make it to the 1. So that's going to be negative 1/6. Negative 2 out of 3. Here's 1 out of 3. Here is 2 out of 3. This is going to be negative 2 out of 3. So therefore, negative 1/6 is closer to the 0, which means it's a bigger number. So negative 2/3 is less than negative 1/6. If we want to make them have the same denominator, we can do that by going multiplying the 2/3. We're going to multiply because we want them to be the same. The bottom by 2, which means we'll have negative 4/6. And so then if we compare that to negative 1/6, negative 4/6 is bigger in the sense that it's a negative. Therefore, it's farther away from the number 0 than negative 1/6. So negative 4/6 is less than negative 1/6. It's a little complicated because you're dealing with negatives. So even though 4/6 looks like a bigger number, because it's a negative, it's actually less than or a smaller number. So now we're going to compare decimals. So same thing, right? Here you have the number 4. Oh, and this should have been a negative. Sorry about that. Add that in. So you have the number 4 and then 10 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's the number 5. So this first one, negative 4.4. Here's negative 4, and sorry, these are negatives. Negative 4, and then 4 spots. 1, 2, 3, 4. Here's negative 4.4. And then here is negative 4.7. 4, 4, 5, 6, 7. So using the number line, 4.4 is bigger than negative 4.7. So you will write that negative 4.7 is less than negative 4.4. Okay. I don't know what I was doing here. I made it so that we were comparing the same numbers. So we can use the same number line up here. So we have negative 4.2. So negative 412. I'll write it up top. Negative 4.2. And then negative 4.9. Which number is closer to 0? 0's this direction. This one. Therefore, it's bigger because we are dealing with the negatives. So negative 4.2 is greater than negative 4.9. So now let's look at ordering rational numbers. So you have 1/4 of a mile, negative 0.2, so 2/10 of a mile. We have negative 2/9 of a mile and 1.1 mile. So we can do this either way. We can turn these into fractions so that we're working all with fractions, or we can turn our fractions into decimal points. So to turn the fractions into decimal points, you divide 4 into 1. So it's would turn out to be 0.25 miles. So then this one's a negative 0.2 miles. Then we have negative 0.2, and it's a repeating decimal, so we'll put a line over the top. And then we have 1.1 miles. So we want to put these in order from least to greatest. Well, greatest, we can already see this is a 1, and that's bigger, and it's positive, so that one's going to be the biggest number. So we're going from least to greatest, so this one is going to be over here. And then we can see that 0.25 is also a positive, so it's going to be less than 0.25. And then, but sorry, we should not write that as 0.25. We should write it in its original form. Oh, and not a less than. And then from there, 0.2, negative 0.2, or negative 0.22222. This one stops after the 2. This one keeps going. So technically it's a bigger negative. So then this one's going to be a negative 0.2. And that is bigger than negative, and do the original form, 2/9. That is our answer. So this next one, we are going to label it least to greatest. Looking at the numbers, we are going to see this one is a positive. So that's going to be the greatest number, because the only other positive we have is a 6. So that's going to be over here. 12.5 degrees Celsius is bigger than 6.55 degrees Celsius. And then we go to the negatives. -4 is closer to 0 than -6. So this is going to be -4 degrees Celsius. And then our least number is -6 1/4 degrees Celsius. Now I want you to define a rational number. See if you can tell me what a rational number is without looking back in your notes. Write it down and then check back to see if you got the correct answer. If you put a rational number as a number that can be written as A over B, but B can't be 0, you're correct. You could also say a rational number is a number that can be written as a quotient of 2 integers. Go ahead and do the next 5 questions on your own. Check back and see if you got them correct. If this is what you got your answers correct. Check those out. Okay, so complete the homework on a separate note page. It's going to be page 28 through 29, number 7 through 27 odds.